So our project is obstacle avoidance with the Phantom Omni robots. And our robot will be given an image consisting of a start location and an end location and an obstacle in there. And it will use the pen attached to the end effector to try to draw a path, a continuous path from the start to the finish without hitting any of the obstacles. The first task of this robot is to draw the corners, denoting where the field is going to be. So we have a mark right there, second mark, third mark, and a fourth mark. Next, I will be drawing an obstacle, and in this case, it'll be a blue circle right at the center over here that filled in. We're going to have a starting location denoted by a green circle right over here, and we'll have a red circle denoting the end location opposite that of the obstacle over here. Next, we will be uploading an image of this to the computer.
Someone get a question?
So now we have uploaded our picture of the field to the computer over here. And what we're going to do first is we're going to run our program. And the first step for this robot is we need to go and mark out, using this GUI over here, where the corners that the robot's drawn were. So we have 1, 2, third point, and a fourth point. Now, what happens in the background is that the computer will go and process the image and run some threshold algorithms to isolate the start location, the end location, and where the obstacles are. This flow of text over here is that it's running the A-star algorithm, a path planning algorithm that uses a priority queue and tries to figure out the shortest distance from the start location to the end location while avoiding the obstacles. This is going to take us some time, maybe about 2 to 3 minutes, because this entire grid is represented as a 10 by 10 array. So in this step over here, you can see that the robot has returned a list of coordinates. This is the path that the robot will trace. And if we scroll up from the terminal window, we can indeed see that the robot thinks the start location is to the left over here. It is denoted by the C. Then it'll start moving down diagonally to the right. It will move diagonally down again, move diagonally down to the right, and starts moving back up. Moves back up, notice avoiding the obstacle, and finally terminates right where our ending location is. And from our A-star algorithm, this robot will need to hit 7 consecutive points to complete this path. Now that we have the path from the A-star algorithm, all that's left to do is for the robot to draw the path from the start to the ending location using the coordinates determined. Moving to the start location, lands right on the dot. And you can see that the robot has almost hit the ending location. And this is because of the resolution of our algorithm. Our algorithm runs on a 10 by 10 grid, but we have some errors and tolerance for the amount of space that's to reach to the end location. However, the most important part is to note that the path actually avoids the entire obstacle, the blue circle, and the path draws around, showing that our algorithm with obstacle avoidance works.